Dear students, I am Dr. Rajeev Sapre. This is lecture number 38 about the topic topology of metric spaces. In previous lecture, we saw that closure of the set, when you take, it is the smallest closed subset of X containing A, right? And I compared it with A interior. In case of interior of the set, we had proved that A interior is the largest open subset of A. Here we are saying A bar is the smallest closed subset containing A, right? Now next property of this closure of the set we will prove is that it is the intersection, A bar is intersection of all closed subsets of X containing A. So that is the next property we will prove. Let XD be the metric space, XD be the metric space, and A be the subset of X, A be subset of X. Then A bar is the intersection of, A bar is the intersection of all closed sets, all closed subsets. This is closed. Sorry, this doesn't seem to be like that. So it is an intersection of all closed subsets of X containing A. Containing A, right? So one intuitively it is very clear. कारण काय बघा, आपण आत्ताच काय प्रूव्ह केलं की A bar हा कसा आहे, स्मॉलेस्ट क्लोज्ड सबसेट ऑफ X कंटेनिंग A. आता काय होणार बघा, समजा मी सर्व क्लोज सबसेट्स घेतले जे A ला कंटेन करतात, या मेट्रिक स्पेस X चे सर्व क्लोज सबसेट्स घेतले जे A ला कंटेन करतात, तर त्यांचं इंटरसेक्शन हा स्मॉलेस्ट, कारण इंटरसेक्शन ऑफ आर्बिट्ररी इंटरसेक्शन ऑफ क्लोज सेट्स इज क्लोज्ड. सो जे काही क्लोज सेट्स असतील मेट्रिक स्पेस X, D चे जे A ला कंटेन करतात, त्यांचं इंटरसेक्शन हा स्मॉलेस्ट क्लोज सबसेट असणार. आणि स्मॉलेस्ट क्लोज सबसेट ऑफ अ मेट्रिक स्पेस X, D विच कंटेन्स A इज A बार. त्याच्यामुळे तो रिझल्ट प्रूव्ह होतो. परंतु आपण अगदी रिगरसली तो प्रूव्ह करूया. सो प्रूफ. Okay, so let suppose I take script f, something like this. Script f is suppose the set of closed subsets, actually f alpha, where alpha belongs to capital f lambda म्हणू आपण, f lambda belonging to capital lambda, where capital lambda is index set, right? B, family of all closed subsets of X, D. B, a family of all closed subsets. कुणाचे हे क्लोज सबसेट्स आहेत ऑफ X, D containing A. Containing A. That means what? Each of this f lambda, म्हणजे समजा हा कॅपिटल लॅम्बडा इज एन इंडेक्स सेट, कुठलाही यातला f लॅम्बडा घेतला, म्हणजे समजा इफ आय टेक fi where I belongs to capital lambda, then A is subset of fi and fi is closed set. Correct? Now you take, let f is equal to, f you take as intersection f lambda belonging to capital lambda. Now what is this? Right? What is this? This is also, this is actually what? Arbitrary intersection of closed sets. So this is a closed set. आपण हे रिझल्ट्स केलेले आहेत की आर्बिट्ररी युनियन ऑफ ओपन सेट्स इज ओपन अँड आर्बिट्ररी इंटरसेक्शन ऑफ क्लोज सेट्स इज क्लोज. सो दिस इज अ क्लोज सेट. आणि ह्यातल्या प्रत्येक एफ लॅम्बडामध्ये ए आहेच, राईट? सो हिअर आय कॅन से लेट एफ इज दिस अँड वी नो दॅट ए इज सबसेट ऑफ एफ लॅम्बडा where lambda belongs to capital lambda. means for all lambda belonging to capital lambda, we can say. Now, as arbitrary intersection of closed sets is closed, as arbitrary intersection of closed sets as arbitrary intersection of closed sets is closed, it implies F is closed. F is closed subset of X. Closed subset of X and as A is subset of F lambda for all lambda belonging to capital lambda, it implies what? It implies A is subset of F. A is subset of F. म्हणजेच काय झालं बघा, F is closed set containing A. ओके, बट आपणाला काय माहिती आहे, A बार हा स्मॉलेस्ट क्लोज सेट असतो containing A. Correct? So at this moment what I can conclude? So F is a closed set. F is closed subset of X. Closed subset of X containing A. Containing A. Right? But we know that A bar is what? Smallest closed subset. A bar is smallest closed subset. Closed subset of X comma D containing A. Containing A. Right? Okay. This implies what? मग हा जो तुम्ही इथे वर काय म्हणताय, F is a closed subset of X containing A, आणि इथे म्हणताय A bar is a smallest closed set containing A, smallest closed subset of X containing A. नॅचरली काय व्हायला पाहिजे, A bar हा F चा सबसेट व्हायला पाहिजे. सो दिस implies A bar is subset of F. Right? Say now this is say 1. Okay. Further, what is A bar? A bar is closed set. Right? Further, A bar is a closed set containing A. So I think I will write it here somewhere. This is the problem of this, that we have to erase. Okay, I will erase this part because this is already noted down by us. So up to this I will erase. Right. Now what is we are interested in? See here, I will erase this part also. Okay. So all these things that we have developed here, what we are now saying, okay, so what now we are saying, that A bar is, so we will say here further A bar is a closed set containing A. A bar is closed set, closed subset of X containing A. This is obvious. Okay. So that implies also what? A bar is a member of that family F that we have defined above. Okay. This implies what? Intersection of that lambda belonging to capital lambda of that F lambda, that is we have taken as F. Okay, that is subset of A bar, and that implies what? F is subset of A bar. This is say result number 2. Here you proved A bar is subset of here you proved F is subset of A bar. So now from 1 and 2 we can say from 1 and 2 we have F is equal to A bar. But what was F? F was intersection of all such closed subsets of X which contained A, right? So that is, this is equal to, A bar is equal to, right? What is this F? F is intersection F lambda, lambda belonging to capital lambda. And हे सर्व सेट्स कसे होते? They were closed subsets of X containing A. आणि या सर्वांचं इंटरसेक्शन, असे सर्व आपण एक फॅमिली घेतली, त्यातले सर्व सेट्स कसे होते? दे वेअर क्लोज सेट्स. बट अजून एक त्याच्यात प्रॉपर्टी होती, दे वेअर कंटेनिंग ए. अशा सर्वांचं इंटरसेक्शन म्हणजेच ए बार आहे, असं आपण इथे प्रूव्ह केलं. ओके, सो आय होप यू अंडरस्टूड. दिस इज व्हेरी सिम्पल इश्यू. परंतु त्याच्यामुळे आता ए बारच्या अनेक प्रॉपर्टीज आपण सिद्ध केलेल्या आहेत, त्यांचं एकदा कन्सोलिडेशन तुम्ही करा. दिस कन्सोलिडेशन हेल्प्स यू. एका ठिकाणी एका ग्लान्समध्ये आपल्याला सर्व प्रॉपर्टीज त्याच्यामुळे कळतात आणि त्या आपल्याला लक्षात ठेवणं गरजेचं आहे. बिकॉज एव्हरी प्रॉपर्टी यू मे नीड समवेअर. विच प्रॉपर्टी यू विल नीड इन विच प्रूफ यू कॅनॉट टेल बिफोरहँड. So it is best to know all the properties that we have proved. So one simple exercise that we can carry is write down all these properties, not only of closure but of interior, of open sets, of closed sets, of metric space, all such things. Consolidation of the results, that is the name that I can give to that exercise. When you consolidate all these results, those results are always open to you. You can go through those results. Try to recollect the proofs of those. त्याच्यामागे काय लॉजिकल रिझनिंग आपण वापरलं होतं ती प्रूफ देताना हे आठवा तुम्ही. असं ऑनेस्ट एफर्ट आपण केले तरच या सर्व प्रूफ्स आणि या सर्व गोष्टी तुमच्या लक्षात राहतील. ओके, सो नाउ वी विल प्रूव्ह वन रिझल्ट which is actually very simple now because of all these results that we have already done. So it is, let x comma d be the metric space. X comma d be the metric space. Okay, A be the subset of X. Then A is closed if and only if A is equal to A bar. Now I think this is very obvious result now, because just we have proved already. What we have proved already? That A bar is what? A bar is the smallest closed set, or we have proved actually A bar is a closed set. हा रिझल्ट आपण ऑलरेडी प्रूव्ह केलेला आहे. A bar is a closed set. Closure of A is closed set. मग जर क्लोजर ऑफ ए क्लोज्ड असेल आणि ए आणि ए बार इक्वल असेल तर ए पण क्लोज्ड आहे. सो वेन एव्हर आय अस्युम ए इज इक्वल टू ए बार, ए इज क्लोज्ड इज फॉलोज, राईट. सो प्रूफ वी कॅन राईट लाईक दिस. Let x comma d be the metric space. Okay, then assume that a is equal to a bar, right? But closure of a bar म्हणजेच काय? Closure of a. So but closure of a, that is a bar, is a closed set. This result is done. Is closed set. So if you have asked this proof in the papers etc., then you have to include that proof here. But here now already we have done all these proofs, so I will use those statements to develop this result. So but A bar is a closed set, hence A bar is equal to A implies A is closed set. A is closed set, right? So this is done. When you assume A is equal to A bar, A is closed is proved. Now conversely what I can say? You are given A is closed. A is closed subset of X. Now when A is closed subset of X, obviously it is the smallest closed subset of X containing A. This is very obvious, right? And in the previous result we have proved A bar is the smallest closed subset of capital X containing A. So it follows A is closed subset of X. This implies A is smallest closed subset of X containing A, right? But A bar is smallest closed subset of X containing A. So that implies A is closed set. So we are playing with the previous results. We should know clearly what are the results that I can use to prove the result, the current result actually. Okay, so this is one important issue that we have proved now, means all the results that we have proved about closure of the set, right from the definition of adherent points, limit points, then we have related closure of the set and limit points also we have related. We have said A bar is A union DA. We have also related the distance between the set and point and this closure. जे adherent points जर असेल, P हा जर त्या सेटचा adherent point असेल, तर what is distance between P and A? It is 0. Right? So all such results we have proved, and they are very, very important. Okay. Now one result follows. Now already it is done by us. What is done by us? That set A is closed if and only if it contains all its limit points. This result we have proved. Now it follows from all these results. This can be considered as a corollary of all these things, of this result itself. See, already you have proved A bar is A union DA. म्हणजेच काय झालं, जर A हा क्लोज सेट असेल तर आत्ताच आपण प्रूव्ह केलं ना, जर A हा क्लोज सेट असेल तर A बार इज A. म्हणजेच A हा कसा असणार, A युनियन DA असणार, कारण A बार म्हणजेच A युनियन DA आहे, म्हणजेच DA हा A चा सबसेट असणार, म्हणजेच इट कंटेन्स ऑल इट्स लिमिट पॉइंट्स. So we will write it as a result and prove it in short. Okay, so let us write down the statement. Already this is, I think, done by us, but now say let X comma D be metric space, right? A is subset of X, then A is closed if and only if derived set of A is subset of A, or in other words, or A contains all its limit points. Okay, this is what I have to prove. So proof, very simple proof. See, suppose A is closed. म्हणजे ते सर्व लिहिलं पाहिजे की let X comma D be the metric space. Okay, we will write it better way. Let X comma D be the metric space. Okay, and A be subset of X. Now A is closed. Let A is closed subset of X. A is closed subset of X. Now we have proved that when set is closed, it is equal to its closure, right? That is, A is equal to A bar. But in previous results we have proved that A bar is what? You can write this as A union DA. आपण हे प्रूव्ह केलंय, A bar is equal to A union DA. पण मग A जर A union DA असेल तर this implies what? Derived set of A is subset of A. That means what? A contains all its limit points. A contains all its limit points. This is one thing. And conversely, if A contains all its limit points, if A contains all its limit points, what does it mean? Derived set of A is subset of A. But that means what? A union derived set of A will be derived set of A जर सबसेट असेल A चा, एखादा B हा A चा सबसेट असेल तर A युनियन B काय असतं? A असतं, मोठा सेट. So it is A. But what is A union DA? A bar. So A bar is equal to A. Here I can give reason as A bar is A union DA. Already this is done by us. पण मग A bar is equal to A याचा अर्थ काय होतो? A bar आणि A जर इक्वल असतील, क्लोजर आणि सेट इक्वल असेल, तर what does it imply? It implies A is closed set. A is closed subset of X. So proved. So this is how these results can be proved. I hope you understand this proof, and we will stop here. In the next lecture I will continue with some other results. Right, we have to study lots of things. We have studied interior set and its properties. Then we define what is limit point, set of all limit points, we call it as a derived set of A and all such things. Closure now we have defined. So we have to study the properties. Suppose A is subset of B, then what will happen to derived set of A and derived set of B? All such results we are not yet done, so we will prove it in the next lectures. Okay, so we will stop here. Thank you.